In this video, we shall be looking at number-based system. So, number-based system. Recall in your junior secondary school, you learnt number-based system, or what we call binary numbers, where we have numbers in base 2, 3, 4, 5, 6, 7, 8, and 9. And also what a binary and denary number is. A binary number is a number in base 2, and denary is a number in base 10. So let's see the following examples. So we are going to be looking at conversion from order basis to base 10. What do I mean by order basis? It could be base 2, it could be base 3, it could be base 4, it could be base 16, it could be base 12. So we are going to be converting from order basis to base 10. So, example, convert the following numbers to base 10. So we are converting 1, 4, 3, 4 base 4, 1, 2, 7 base 8, 8b, 3a base 12. Solution. So we are starting with the first one. We are converting 4, 3, 2 base 4 to base 10. So what do? I told you, in doing this, we put the powers starting from 0 in increasing order from the left. We are familiar with this in our previous video in GSS classes. So in doing this now, so I have 0, 1, 2. So this is base 4, we are converting to base 10. So what do we do next? So we multiply out, we do our expansion. So I have 4 times 4 raised to power 2. The reason why I'm having 4 raised to power 2 is because we are converting to base 4. So I have 4 times 4 raised to power 2. I have 3 times 4 raised to power 1. And I have 2 times 4 raised to power 0. Can you see that? So this will give me 4 times 16. 16 here is because I have 4 raised to power 2. That's 4 times 4 will give me 16. I have 3 times 4. And I have 2 times 1. 4 raised to power 0 will give me 1. Anything raised to power 0 will always give you 1. So I have 4 times 16 to be 64, 3 times 4 to be 12, and 2 times 1 to be 2. So adding these together, I have 78. 2. I'll be converting 1, 2, 7 base 8 to base 10. So what do I do here? I label again, so I have 0, 1, 2. So I have 1 times 8 raised to power 2 plus 2 times 8 raised to power 1 plus 7 times 8 raised to power 0. So this will give me 1 times 64. 8 raised to power 2 will give me 64 plus 2 times 8 plus 7 times 1. So this will give me 64 plus 16 plus 7. So adding this together will give me 87 base 10. So lastly, we'll be doing 8b, 3a base 12. Are you a little confused? You are seeing letters within numbers. What you call this is alphanumeric numbers. Alphanumeric number are numbers that comprise of letters and digits. So this type of number is called an alphanumeric number. So not to worry yourself about that. Note that we have the number to be in base 12. Okay, and we are familiar with single base system, but we still use the same approach in solving it. So let me tell you what the letters here represents. So I have my A to represent 10, I have my B to denote 11, my C to denote 12, D is 13, E is 14, and F is 15, and so on. So these are what the letter represents in numbers. The reason why we can't write it out is, if I want to write, is because we have bases that are bigger than 2 digits. That is why we represent 2 digits with letters. So let's solve. I have 8b 3a. So what do? I put my powers. I have 0, 1, 2, 3. So here in expressing this, I have 8 times 12 raised to power 3 plus my b is 11, so I have 11 times 12 raised to power 3 plus 3 times 12 raised to power 1 plus my a is 10, so plus 10 times 12 raised to power 0. So 12 raised to power 3 will give me 1028. So I have 8 times 1028, 728 plus 11 times 144 plus 3 times 12 plus 10 times 1. So 8 times 1728 will give me 13,824 plus 1,584 plus 36 plus 10. So adding these together, I have 15,454.